What's up, guys? We are back for Cerebrum video number 2. We're just focusing in this video on the frontal lobe. And so if you look at this blue highlighted portion here, that is the primary motor cortex. The anatomical name for this structure is the precentral gyrus. It is the most posterior portion of the frontal lobe just before we hit the central sulcus, which is the division between the frontal and the parietal lobes. You'll notice that it's also labeled as M1. That's just shorthand to describe the primary motor cortex. And the job of the primary motor cortex is to control voluntary movement. And so when we execute a voluntary movement, it's this portion that has the largest responsibility in us carrying out that voluntary movement. So the yellow portion right down here that goes all the way up to that green area, that is the premotor cortex. The premotor cortex is also involved in voluntary movements, but it is involved in externally guided movements, and I'll explain a little bit what that means. But it is responsible for us making postural adjustments for skilled movements, and it's also very communicative with a portion of our brain called the basal ganglia. I won't go super in depth about the basal ganglia in this video. I'll save that for a future video. But just to know that the basal ganglia has a lot of responsibility in making sure that we are producing the size and force of movement that we intend to. So for instance, if I'm going to try to throw a dodgeball at someone, I'm going to be moving with a different size and force of movement than if I'm trying to reach for a hot cup of coffee off of the table, right? So the premotor cortex works with the basal ganglia to ensure that I'm going to move with the appropriate size and force of movement. Now, I said that it is utilized in externally guided movement, and what that means is movement that is guided by an external cue. So for instance, like following a GPS, it tells you to turn left, and so then our behavior is that we turn left. Another good example would be if you were on the field in baseball, or let's say football, and you look to your coach and he gives you a certain sign, your next action or movement is going to be based on the external cue that was given by your coach. And so think premotor cortex is going to be largely driven by any external cues, our reactions to external cues. Now that green area, the supplementary motor area or supplementary motor cortex, is more responsible for internally initiated actions instead of those that occur in response to an external event. So the supplementary motor cortex is going to be more active when we're doing a movement sequencing that's largely coming from our memory. And so think about, like, if you're playing a complex piece of music on the piano or guitar, this is something that you've practiced over and over again. It's not necessarily something that you're reading off the page, which would be more of like an external cue, right? But it's something that is just ingrained in you now, and so you know how to produce the movements. Those internalized or internally cued movements are going to be directed by that supplementary motor cortex. Now, along with that, the supplementary motor cortex is going to be largely involved in bimanual coordination, which makes sense when I talked about just a second ago the instruments, because bimanual coordination, if you're playing piano, if you're playing guitar, playing violin, playing drums even, and then even something as silly as like juggling, right? So the supplementary motor cortex is going to be involved in any complex bimanual coordination tasks, as well as the timing and rhythm of those movements to produce the successful movement that you're aiming for. It also is triggered with the start of, or it triggers rather, the start of a voluntary movement. So the next area I want to talk about is the frontal eye field. It's the small red highlighted area there, and that is responsible for conjugating eye movements and just being able to ensure that your eyes are moving together. This next blue highlighted area is known as Broca's area, and it is responsible for motor speech. So in particular, orchestrating the muscle movements required for articulating spoken words. Interestingly enough, this area does exist in both the left and right hemispheres. In right-handed people, the left side of the brain is considered our dominant hemisphere. And in right-handed people, the language centers in our brain tend to be larger on the dominant side. In left-handed people, they typically have a right-sided dominant hemisphere. But interestingly enough, left-handed people tend to have language centers of more equal size bilaterally or in both hemispheres. And I just think that's an interesting thing to point out. So if a person has a stroke or some sort of infarct to a blood vessel that supplies Broca's area up there, then you can imagine it's going to dramatically affect their motor speech or their ability to coordinate the movement to articulate the speech that they're intending to produce. And finally, we have the prefrontal cortex, that large blue portion there. It is responsible for our concentration, our conceptualization, judgment, critical thinking, problem solving, and planning. So you can imagine that a person who has like a traumatic brain injury or an acquired brain injury due to a stroke or something like that, that affects this area would have deficits in their judgment. They may be a little bit less inhibited, meaning that they're less likely to fully plan out their movements or process out their movements, which makes them, potentially a little bit more unsafe because they may also not have realistic perceptions of what their deficits are.